welcome John Penny, a very special guest from Twinsburg, Ohio. 30 years ago, John started in the field as a generator mechanic. Today, John is the service manager for Buckeye Power Sales. John Penny was one of the original beta testers of the Electrical Generator Systems Association, EPSS certification. Today, John trains and mentors the next generation of EPSS certified technicians. His team is responsible to maintain and service the emergency power system for thousands of customers throughout the region, and to make sure those systems are compliant with the NFPA 10 code. We all know that power systems are comprised of mechanical components, and those mechanical components will wear out or fail if they're not replaced or properly maintained. John is here today to teach you how to make sure your emergency power system is there for you when you need it the most. With that, I ask that you turn your full attention to John Penny and help me welcome him to the podium. John Penny.
Thank you. Like you said, I am John Penny, the service manager for Buckeye Power Sales in Cleveland, Ohio. And we're here today to talk about generator reliability and actually a little bit more than that, the entire emergency power supply systems, which is more than just the generator. As facility folks, everybody always thinks of the generator, but a lot of times the rest of the system gets neglected. So we're going to talk about what the responsibility is of the operators at your facility and what is the maintenance requirements that need to be done to the equipment, the testing that there is to be done with the equipment. So we have weekly tests, monthly, quarterly, annual checks. We're going to talk about the documentation that you need to keep, and we're going to talk about the maintenance that needs to be done, everything monthly, annually, every 2 years, every 3 years, in addition to fuel management, monitoring, etc. So the question that we have based this on, or the principle that we based this on, is NFPA 110, which is the code that governs life safety. And you say, well, this is IT, this isn't life safety, but most of you here would probably say that your equipment and your business is more important than life safety. The reason we used NFPA 110 is it happens to be the highest written spec that we have on what our maintenance should be. And everybody's goal is the same, uptime. You want that reliability, that try to get that 99.99% uptime. And to get there, we have to do certain things on our end to assure that. So we take NFPA 110, which is our highest standard that we have, and we're going to discuss things in there that in the code, there are things that it says you shall do, and shall means it is to be done. Should is also in there, and of course should, we all know, means that it's a recommendation, but they're not going to hold you to it. If you want to take and strive for that uptime, the way that we're going to do that is take all of the shalls and all of the shoulds to try to alleviate that risk. So why do we care about maintenance? Why do we care about generator maintenance? Well, the American Hospital Association did a survey here real recently of 370 power outages. 98% of them worked fine. The 2% that didn't, there were 5 with transfer switch failures. There was a failed hose, a coolant leak, 1 overheated, 1 failed turbo. So all of those items on there, all of them except maybe the failed turbo, can be attributed to lack of operation and lack of maintenance. We always talk about the generator, and everybody always wants to test the generator and run the generator, but when I come into the facility and say, okay, now we have to put that generator onto your site and transfer the transfer switch, it's going to take an act of Congress to get that done. Well, if you don't operate a piece of equipment and it sits and it sits, it's not probably going to operate when you need it to. So that's why we want to look at these, because of these failures, 89% of them were due to lack of maintenance. So we're going to start by talking about what is the EPSS, or the Emergency Power Supply System. It's comprised of the emergency power supply, which is the generator, but there's more than just the generator to your facility. There's the generator, there's the potentially multi-unit paralleling switchgear, you have transfer switches, you have batteries and battery chargers, you have potentially fire pumps and fire pump controls. The UPS is part of your EPSS, and you have remote annunciation or monitoring of the equipment. Okay? So this is what makes up your supply: the generator, the transfer switch, the UPS, the fuel supply itself. You may have, we'll talk about that in a minute, batteries and chargers, fire pumps, and the load conductors themselves. And we'll discuss the maintenance requirements of those as we go. The generator can be, one generator can be a number of different generators. They can be indoors or outdoors. They can be in sound attenuated housings. They can be any number of combinations. We talk about the batteries and the chargers. The batteries on that generator are probably the weakest link on the generator, right? That battery fails, that generator's not going to start. We have battery chargers because the controls are always draining power from those batteries, so we have to have a charger to keep them charged up. You have to have a transfer switch or some sort of a device that switches between the utility source and the generator. We also have remote annunciators. These are just mimic panels that take the controls from the generator, the alarms, and puts them in some place where they are monitored. Because if the generator's outside in a housing, out in the back of the facility, you're not going to hear the alarm when it has a low fuel alarm. So we have the remote annunciators that we have to look at to let you know when there's an issue. You have potentially, if you have more than one generator, you have potentially the paralleling switchgear. Like we said, fire pump controls, UPSs. Another part of it is the fuel system, right? So the fuel system can be made up simply as a sub-base fuel tank, like in the case of this generator where it sits on its own fuel tank. It's a single generator, it's big enough to run the entire facility, and it has, let's just say, a 24-hour fuel tank. But maybe for your facility, 24 hours at one time is insufficient, so you may need some sort of other storage tank, whether it be an underground, an above-ground convault, or any other type of tank, and then some sort of a day tank that draws that fuel from those other tanks and brings it to the machine so it can use that. Pretty straightforward. The other part is the load conductors, the cabling, and we'll talk a little bit more about that when we talk about infrared. Now, I do want to take a couple of minutes here just to discuss tiers, because there is a difference in our industry and the generator industry versus your industry. There's two definitions of tiers. There's what the EPA considers tier 1 through 4, and then there's what the Uptime Institute considers tiers 1 through 4. Sometimes, especially as we're speccing equipment, these terms get mixed up, and they are completely different in nature. The EPA tier 1 through 4 has to do with engine emissions and nothing to do with uptime or productivity. The Uptime Institute is describing the type of installation that you have, whether it's a single generator, etc. We'll talk about that. How many tier 4, uptime tier 4 facilities do we have represented here? Ooh, okay. So, are you all at the same facility? Okay. Probably most of you are tier 1, 2, or 3 aspiring to be a tier 4, right? It has everything to do with the power system itself. On the generator side, we have tier that has to do with the amount of emissions from the engines. And that's all it is. It has nothing to do with your reliability. From a performance standpoint, for uptime, we talk about the tiers, and that's what gets you at a tier 4, gets you that 99.995% uptime. And just as a quick line diagram, a tier 1 is going to have a single utility, a single generator, and probably a single UPS. A tier 2 could have 2 generators and 2 UPSs. A tier 3 is going to have a second utility, and you may share the generators. And a tier 4 is completely redundant with 2 different sets of generators, 2 utilities, redundant UPSs, the ability to split the bus or tie the bus as necessary. Okay. When we talk about generator tier ratings, it basically comes down to whether the generator is supposed to be rated for its standby rating or its prime power. There's a misconception that to be tier 4 compliant on your uptime, that the generator has to be a prime power generator. But when we look at the diagram here, you already have 2 different utility sources. So what's your primary source of power going to be? The utility, not the generator. The generator is not going to be your prime power. Therefore, what it comes down to is the generator doesn't have to be rated for prime power for tier 4. We can use the standby rating. Any questions on that before we move on? Okay, so let's talk about the reliability. What, as an operator or facilities operator, that need to be done per NFPA 110, and that's what we're basing this on. Okay, there is a weekly checklist that is published in NFPA 110. You'll see some examples up here as we go, but we also have hard copies of one that's a little bit easier to navigate back at our table. And if you're interested and you give us your email, we have it available as a Excel spreadsheet so that you can just fill that in electronically. So weekly, we want to do a few things. We want to make sure that we're checking the fuel level, we're inspecting the batteries. We want to make sure that the generator is exercising weekly, even if it's unloaded. It's our responsibility to record the gauge and meter readings, and then when you're done, make sure that everything is ready to go, that the unit's back in automatic, and that the circuit breaker is closed if you've opened it. The monthly checklist is very similar. The monthly checklist, we inspect it per that checklist. It also tells us that we have to check the electrolyte levels in the battery, okay? Or we can perform a conductance test. Now, checking the electrolyte in the batteries monthly requires a whole set of PPE because you're taking the caps off of a battery and you're looking at electrolyte. So there's a set of, you have to take, have the proper training, the proper PPE to make sure that you're doing that in a safe manner. We'll kind of touch bases on that a little bit more. Monthly, it also says that the EPSS, or the entire system, shall be tested under load a minimum of 1 hour at a minimum of a 30% nameplate rated load. Now, most generators out there don't have 30% nameplate rated load on it, so we'll discuss what you have to do in this situation. But if this is an NFPA 110 site, we have to test this generator under load for an hour total. Okay? How many people here do that? Good, our same group here. I've got a data center right now that about 6 years ago, they put in a single generator and a single service entrance rated transfer switch. They will never permit anybody to transfer the transfer switch. So 6 years later, they had a power outage, and guess what happened? The transfer switch didn't transfer. And we have been telling them over and over again that, look, this stuff has to be maintained. It was a breaker-based switch. It needs to be operated. It needs to be exercised, and they wouldn't do it. We had a representative out from the breaker manufacturer, told them the same thing. They won't do it. And for whatever reason, they're so hard-headed now, they're just going to kick the can down the road another 5 years. They want to replace the whole transfer switch because they have no confidence in this switch. Well, They're going to have the same problem in 5 years if they don't actually transfer that switch. Again, we have to record the gauge and meter readings and verify the last thing that you're done, if you've manually operated anything, that the controls are in automatic and the breaker's closed. It tells us quarterly that we have to check the fuel strainer, if applicable. Not every machine has it. Some machines have Raycor filters that have a clear base to them that you can see if there's water or dirt in them. Checking the crankcase beaver, it's on there. There's really not a whole lot to check except make sure that wasps or bees haven't built a nest in the outlet of that and clog it up. We're supposed to check and do a visual inspection for any fire hazards. Clean and tighten the battery connections. So how do we do that? We have to take them off, which means we have to take the generator offline to do that, right? Because once you disconnect the batteries, the generator's going to be offline. Annually, it says that we have to follow the manufacturer's recommendation for maintenance. And that doesn't matter who the manufacturer of the equipment is, if it's CAT, if it's Kohler, whatever, they all have their manufacturer's recommendation for maintenance. As a general rule of thumb, it's once a year or every 250 operating hours, whichever comes first. And in almost every case, that once a year is going to come first, right? Some manufacturers will allow for sample testing, but either way, you have to file that manufacturer's recommendation. NFPA 110 also says that you shall have a fuel analysis annually by a certified lab. Anybody taking fuel samples and having it? Okay, good. A good portion of you. That's a good thing. Because that fuel goes in there, and if you've got a 1,500-gallon tank, and you put the fuel in there and you're burning 300 gallons a year, it's going to take a long time to cycle that fuel through. So we want to make sure that we're sampling and testing that fuel, and when the results come back, if it says that we have to treat for microbes, then we can do that. If it says it's dirty, then it can be filtered. So once a year, we take that. If the site doesn't meet 30% nameplate rated load for diesel generators, then we have to do a load bank test, which is just what it sounds like. You bring a giant toaster out, hook it up to the generator, and you run it under load. 50% for 30 minutes, then 75% for the next hour. Okay, that's what code tells us to do. Now, for healthcare, it's kind of a sticky thing. If you happen to have a spark-ignited generator, runs on natural gas or propane, the older code says, or the older code gives you the option of, if you don't have 30% nameplate rated load, it gives you the option of doing the load bank test. In the spark-ignited section, it doesn't give you that option. It says you shall exercise it once a year at 30%, or once a month at 30% nameplate rated load. And it's being enforced by the Ohio Department of Health as you have to add more load to your generator so that you meet that 30% nameplate. Even though newer versions of the code allow you to just use whatever load there is on the natural gas. But chances are none of you here have spark-ignited units, correct? Everybody's diesel? Okay. So if you don't have that 30%, then we need to load bank it. Even if you have that 30%, the load bank testing annually is a good idea, because anything or any weakness in a machine is going to come to be evident under that test. Just like when he was talking about, you don't know what that bus bar is going to do until you put that full load on it. You don't know how it's going to react at low load. That generator could be perfectly fine running at 35% load. But let's just say you add load onto it, and now it's at 60% load, and it's never run at that. There's no guarantee that that machine is going to work. Also, there's no guarantee, you would rather have a failure when you're testing it than when you're 18 hours into a 24-hour power outage. So when you're putting it under load, you want to think of it like taking a stress test or putting a car on a dyno. Any weakness that that machine has is going to become evident during that load bank testing. And again, we're going to record it, we're going to document it, and we're going to make sure everything's back into automatic when we're ready to go. So this is a should. NFPA 110 says that your batteries should be replaced every 24 to 30 months. Okay? We've discussed it's the weakest link, even though I know that you're checking those batteries monthly, you're making sure that they're maintained, and the battery in your car is warranted for 5 years or 7 years. Why should I put out the money for a new set of batteries every 2 years? Okay? Let's talk a minute about how a battery was designed to work. A battery is designed to have a big initial discharge and then charge back up. How we're using them in UPSs, how we're using them in generators, is there's always that constant little draw on it. And we have to constantly recharge it, or after a couple of days, the battery would go dead. So that means that the lifespan is, the duty cycle is a lot more than it is in an automobile, so the lifespan is going to be shorter. But again, do you want, if you've only got one generator at your facility, do you want to take a risk of relying on a battery that's 2 years old, or should you just replace it? So that's a should, but since we're talking reliability, those are things that need to happen. Then every 3 years, we should be servicing the cooling system, right? Belts, hoses, thermostats, coolant, radiator caps, making sure radiators are pressure cleaned out, air filters being replaced. If it's a dirty environment, it may need more than that. Okay? Again, by the manufacturer's recommendation, again, this may seem like a little bit of overkill, but if you get into the habit of every 3 years, you do this maintenance in addition to your normal maintenance, then what are we doing? We're just trying to mitigate that potential issue. So this is what is in NFPA 110 that tells you, this is your checklist, and it shows you, and I hate this term, but everybody always has a PowerPoint and they always say, I know you can't read this slide, and that's what I call a why bother slide. If you can't read it, why bother putting it in? I'm sorry, you can't read this slide, so it's a why bother slide. But what we have here is it tells you in this chart what we have to look at. Under the fuel system, day tank level. Well, how often do we do that? We're supposed to check the level every week if it's a level 1 or level 2. Now, these level 1 and level 2 are not what you think of as level 1 and level 2 data centers. This is geared towards the healthcare industry. So level 1 and level 2 are just different versions of healthcare. Basically, life safety is level 1. It directly affects life safety. If we lose power on this circuit, people can die. Level 2 is life safety, but not quite as critical. It could be your egress lighting. It could be monitoring, but it's not necessarily an operating room that if it goes dead, very bad things could happen. So again, we're wanting to take the highest level that we have and apply it to you so that you can have the best chance of having that 99% reliability. So use the level 1 here. So once a week, you need to check that fuel level, right? And the checklist continues on down through the oil system and the cooling system. It's basically like a 2-page chart as it continues down, and it tells you what to do weekly, what to do monthly, what to do annually. It tells you whether you should check, change, clean, or test, visually inspect. So this is that chart that you do before you even start the machine. This is that pre-start checklist, and this tells you when to do it. Again, we have a simplified version that makes it a little bit more sense of this available back at our table. The other is the maintenance log, and this goes hand in hand with the checklist. Again, this maintenance log is basically the same, except you have a space for date and some sort of identification of who did the service, whether you should weekly check the day tank, whether you should quarterly check the transfer pump, annually check the tank vents, annually inspect the piping, check the oil level weekly, change the oil once a year, check the lube oil heater, check the crankcase. So this is where you document that you check that. And then it goes on to have a place for you to document the voltage and the oil pressure and the coolant temperature. When you're doing that monthly transfer test, you can document how long it took the system to transfer over. So this is what that looks like. This is the checklist that we have. Again, I'm sorry. Up there it's kind of hard to see, but it's the same thing. It has date and the operator's name, and then you check the battery and you check the coolant level and the block heater, the belts, and you can write down when you've done that. The same thing for the test report. You write down the voltage, the current, the load that's actually on it. One of the things that gets a lot of neglect on generators is fuel maintenance. Now, a lot of you here are doing fuel sample testing, which is good, and hopefully then that means along with that, you're doing the rest of the maintenance that needs to be done to the fuel. So you draw a sample, you have it tested, and it says it's dirty. Okay, that's a relatively simple process. You can filter the dirt out. You have it sampled by an accredited lab, and it comes back that there's water in the fuel. Okay, that's relatively simple. You can draw the water off. Usually you're doing that at the same time that you're filtering it. The same machine will do both. If it comes back that the microbes are high, okay, that's pretty easy. It can be tested, tells you how much, and then it can be treated to kill those microbes. If the cetane level needs adjusted, it tells us in the report. Cetane is to diesel fuel what octane is to gasoline. Okay? So it just it tells us what's the combustibility of that fuel. So the cetane, if it's getting older and it's getting weaker, that can also be adjusted. Now, one of the biggest causes of microbe growth is water. It can't live in the fuel itself. They live in the water. And one of the biggest causes of water in the fuel is not necessarily the delivery truck. It's when the tank is not close to full, and you can't fill it completely full. But diesel fuel really expands and contracts with the outside temperature. So what happens is when it gets really warm out, the fuel expands, and then when it gets cold, the fuel may have been touching the top of the tank, and it condenses as it cools. So you get that condensation on the top of the tank, which becomes water, and that's where more of the water comes in. So one of the best recommendations is, as you're getting ready to head into winter, so right now, make sure that your fuel tanks are at 90%. Never fill them to 100%, because if you get a hot day like today, it can expand too much and then purge out the vent, and then you have an environmental mess. So get them full to 90%. That will help alleviate some of that expansion and contraction. And I know this in NFPA 110 is a should, but all the manufacturers will tell you it's a shall. Never use biodiesel in an emergency generator. Biodiesel is fine if you're going to put it in your tractor or your truck and you're going to burn it within the next 30 days. But when it sits, it does such a good job of cleaning the fuel system inside the engine that it just cleans everything out of the fuel system and trashes the fuel system. Most engine manufacturers will not warranty a fuel system damaged engine if it's got biodiesel in it. Some engine manufacturers go to the extreme of saying, if you use biodiesel in your engine, it completely voids the entire engine warranty. Well, it's kind of ridiculous because what would that have to do with, say, a water pump? Nothing. So some manufacturers will go and say, okay, if you just choose to use biodiesel in your machine, we will warranty the engine as normal. However, if it's a fuel-related failure or any related failure in the fuel system, there will not be warranty coverage. We see this firsthand all the time at NASA because the government has mandated them that they have to use biodiesel in everything. So about once every 2 years on a lot of their machines, we have to completely rebuild the fuel system because it's just trashed it out. So while it may be the latest green product out there, please don't ever use it in your stuff. Filtering can be done with many different types of filtering machines. If you have large underground tanks, there are plenty of companies that come out and can service those entire underground tanks. For smaller tanks, sub-base tanks, then there's usually portable systems like this that filter the fuel. The load bank testing that we talked about is done by using a resistive load bank, runs it up to 100% or 75% or whatever you choose it to be, because this isn't life safety. You need to run it to at least 75%. If it were a life safety, it says we have to run it to 75% once a year. If it's joint commission, which is the people who oversee hospitals, then once every 3 years it has to be done for 4 hours, and the second 2 hours has to be at 100%. So the more load you can put on that machine, the better that it's going to be. Even, like we said, even when it's not wet stacking. And that's what this is all about. This is all about when a machine is lightly loaded, we get a concept called wet stacking. And basically what wet stacking is the machine doesn't burn all the fuel that's injected into the cylinder. So it builds up as carbon on the pistons and the valves and the injector tips. So you lose horsepower, you lose performance. The load bank test takes and blows all that stuff out. Some of you here may be old enough to remember back in the 70s when we had the big land yachts. You had to, like once a month at a minimum, take it out on the highway and blow it out. Kind of the same principle. Okay? So load bank testing is done just with a portable load bank. It's just a giant resistive heater that allows us to put it under load. The second major portion of your EPSS is the transfer switch. This is the area of the most contention when it comes to testing, because you have the facilities people over here that say we have to test this transfer switch. Code says we should do it monthly. We need to do it to make sure that it works. IT's over here saying, no, I cannot afford any type of an outage, and there's a giant wall between them. Okay? We have to come up with a way of bridging that gap between facilities and IT to make sure that these can be done. And a lot of it has to do with the type of equipment that's specified. So if you have the opportunity to specify the equipment, there are different types of transfer switches. There's the standard one, which is just an open transition, which means we break from one source before we connect to the other source. So you've got a little bit of a blip when we're testing. There's a program transition, which goes from one source to a neutral position and then goes to the other. So that outage is extended, but if you have heavy motor loads, the idea between that is it stays in the center position for a few seconds to let those motors finish turning down before you reapply power to it. And then there's what's known as closed transition transfer switches, which means we make to one source before we break from the other. Obviously, in a power failure situation, it's not going to make any difference. The power is going to fail. We're going to go over open. But when we come back, you can do it so that you don't see that transition. The closed transition makes it a whole lot easier to do that monthly test because you don't see any type of a bump. Another thing that you can want to consider would be what's known as a bypass isolation transfer switch. This is a transfer switch with a series of another routing around it, just like your UPS has a bypass, a maintenance bypass. It has the same basic principle incorporated. So if we want to test the transfer switch and not affect the facility whatsoever, we can bypass the load to the utility. The transfer switch can rack out to a position where it can be tested electrically. It doesn't affect the load whatsoever, and then we can put it back in, unbypass it, and it goes back to normal. The other advantage of a bypass isolation switch is if the contactor itself needs service, you can put it to the maintenance bypass, draw that contactor out, do all the work that needs to be done, but the facility never had an interruption. Okay? Transfer switch maintenance gets neglected a lot because to do this, it has to be powered down. So again, we're back to that single point of failure that we've talked about. Okay? Part of the maintenance is looking at the connection, looking for corrosion, looking for dirt. Thermal imaging, it was touched on just recently, and looking at resistance and voltage drop against the contactors and cleaning the parts. This takes about 2 hours to do a good, proper maintenance on the transfer switch, and it has to be de-energized to do it, because just like we talked about, NFPA 70E and OSHA did not permit us to do this hot. Okay? So this ends up being neglected, but if you want that reliability, then you need to have some other sources of power to do that. This is a picture, we were talking about the infrared technology that we use for maintenance. Again, you have to put on the proper PPE. In our lightning round video, you saw the technician with the PPE open the transfer switch door with the infrared camera and take a picture. Like it was discussed, you have to put it under load to be able to see it. The darker, the redder the color, the higher the heat, right? So we can see here, this is a picture of a motor starter and some fuses up here. And look here, we have 3 wires. This connection point is showing white hot, and this wire is showing white hot compared to these other 2. So this picture right here shows us, wow, either we have a serious unbalance of the load right there, it's seriously overloaded, or more than likely that contact is loose. That wire is not making a good connection in there. Okay? So that thermal imaging should be part of your annual maintenance of not just the generator and transfer switch, but switch gear and the rest of your utility. So the shoulds that they recommend, again, these are just, if you want to take it to that level to make sure to try to alleviate all issues. One of the shoulds is that there should be a manual stop of the generator outside of the generator housing, and preferably away from the generator. Now, the chances of your generator ever catching on fire are extremely, extremely slim. But if Rocky Raccoon gets into the generator while it's running and it's getting ugly, you don't want to have to get into that housing to shut that generator off, right? So you should have a remote stop, the ability to stop that generator from someplace else. Was touched on earlier, the entire electrical system has to have a coordination study done. This is to prevent, and I saw this happen at a hospital, an outpatient place, where the coordination study wasn't done properly. They plugged in a refrigerator into a receptacle. The building main tripped. 1200 amp main tripped because of this little shorted refrigerator. Okay? I don't want to be in that position. So have that coordination study that was talked about during the commissioning is critical. In some areas, make sure that your equipment's higher than flood levels. You know, if you're in Johnstown, Pennsylvania, if you've ever been there, the generators are all about 20 feet off of the deck because of the potential floodplain. You need to have the infrastructure to hook up load banks, and you really need to have the infrastructure to hook up portable roll-up generators if you're a level 1, a tier 1 facility. Because once the generator has an issue where you say, okay, hey, I need to load bank this generator, or the generator has to be offline for this cooling system service that's going to take 6 hours to accomplish, that's not the time to be thinking about how am I going to hook up 1,000 kW rental generator to my facility. Okay? So the infrastructure needs to be there, and there's a number of different manufacturers out there that make devices that have manual transfer switches in them. Some of them do, some of them it's just a connection point for us to hook a load bank up to, also a connection point to hook up rental generators. So you should, it says you shouldn't contain biodiesel. We've already discussed that you just don't need to do that. Keep the fuel topped off, replace the batteries. Oil sampling and coolant sampling can be just as important as your fuel sampling. Oil sampling will show you if you have engine wear. Coolant testing and sampling can be a formal lab test, or it can be on-site test. But you want to look for the freeze protection of the antifreeze, the corrosion inhibitors, looking for the dirt, looking for the pH level. So those are all very good things to add into your planned maintenance program. The code says you shall, follow the maintenance. It says you shall have 36 inches clearance on all sides. That means the transfer switch has to have 36-inch clearance in front of it. The generator has to be on all sides. Big box stores are the worst. You go into the electrical room and they've got display racks and product all stacked up in front of the electrical gear. The folks here, that's not going to be an issue, I'm sure. You need to have 2 sets of manuals, one near the equipment and one someplace else. The batteries should be tested monthly. Your fuel checked in, you're tested annually, load bank monthly. And at a level 1 site for life safety, the breakers in the system have to be exercised annually. Because if a breaker just sits and sits and sits and never gets exercised, if it's tripped, there's no guarantee it's going to reclose. The last part that I want to talk about is who should be servicing your EPSS. There are a number of people out there that will come out and say, hey, I can change your oil. But you want to look for factory-trained personnel and EGSA-trained personnel. EGSA is the generator industry's organization body. We sat and said we need to have certification of generator technicians that's not product-specific. So EGSA is to us what ASE is to the automotive industry. So you want to look for technicians that are EGSA. Obviously, you want them to be fully insured, drug screened, background checked, and must transport and dispose of used fluids and hazardous material in an approved way. Because as the owner, technically you're responsible for that, whatever, that battery that came out of the generator, the oil that came out of the generator, and if your guy takes it and dumps it on the side of the road, it's your responsibility. So you want to make sure that your folks are doing things properly. And then they need to have some common sense. Now I pray that this was just a staged picture, but since it's hard to tell, but this is a 220 European plug, and there's a lot of alcohol involved there. I doubt that it was staged. So is that what's known as a floating ground? The people that we touched on this, you have to have that proper PPE. They need to have proper safety training, which includes arc flash training and spill training. So as we touched on, you cannot work on things hot, but you can test. So a meter, but you have to have your full arc flash. Again, the arc flash gear is not there to make it so you can work on it hot. The arc flash gear is there to supposedly make you survive the explosion. Now you're probably going to be deaf because the sound pressure wave is going to rupture your eardrums. You're still going to be burnt with 2nd-degree burns over, I think they say 30 or 40% of the body is still acceptable, but the arc flash gear is to try to prevent the burns from getting worse than 2nd degree. So your folks have to be, that are doing the service, have to be proper trained. And then the last part is your monitoring, whether it's as simple as the remote annunciator, whether it's an old system of dry contacts that's tied into your building management, whether it's using some sort of protocol like Modbus or KBus that ties in, excuse me, a manufacturer-specific software, or there's a number of third-party people out there that have monitoring devices. So whenever the generator runs, it sends you an email, sends you a text to your phone, generates a log so that you have that in addition. So now we're basically at the point where, what questions do you have? Sir?
So the thing about testing the EPSS under load, is that technically the whole system, I mean, down the switch gear? Because depending on how your load bank that, or what happens, that happens with high load?
It does not have to be, well, in a healthcare setting, okay, the transfer switch itself has to transfer. Now, if that transfer switch, or if it's paralleling gear, is still going to be feeding your load, right? Even if there's a utility coming in, you're still having to feed a live load. Now, you can supplement in that paralleling gear. You can have a breaker set up for a load bank that you could supplement that load. But the gear itself, or the transfer mechanism, by NFPA 110 still has to transfer monthly. The result of wet stacking is lack of horsepower. Just like the old cars in the 70s, it wouldn't run very well. When you've got all that carbon in there, you don't have all your horsepower available. Eventually, what will start happening is the fuel coming out of the injectors won't be atomized properly, or it may come out all of one hole, and it'll start literally creating a jet and make holes in your pistons if it gets bad enough. So it's all performance and horsepower related. Any other questions? Well, if there's any other questions that come up, okay, we got one here. It's a simple test device, relatively inexpensive, that basically you put onto the device, onto the battery itself, and it does more than just like a standard load tester is a carbon pile that would put a load on it. A conductance test actually puts a small load through it, but it checks the electrical circuit through the entire battery using this piece of test device. It's still not going to tell you where the electrolyte levels are, but if it's a sealed battery, that's what you have to do. And quite frankly, the cost of that is probably less, and it's probably a whole lot safer than taking the caps off of the battery. I didn't mention this because it should be common sense, but we all know that common sense isn't. When you're checking the electrolyte or doing anything with the battery, no smoking. You know, ideally, that's really something that as an operator, you're not required to do. The operator maintenance just requires you to look at the level. The maintenance side requires the specific gravity test. If you do have to top off the fluid in the battery, only use distilled water. Never add acid to a battery that's already charged up. Any other questions? Well, that's about my time, so if you have any other questions, we'll be back at the table. There's copies of the pre-checklist and the report back there. If you're interested in getting that Excel report emailed to you, just give us your contact info and we'll be happy to do that for you.